Hello, my name is Joachim Schultze and I'm a scientist at the German Center for Neurodegenerative Diseases in Bonn, Germany. I'm working at the interface between the computational sciences, genomics, medicine and immunology. And today I would like to show you what we are doing to break down walls in science. When the Berlin Wall came down, I was a medical student in Tübingen, Germany. I came out of a lecture hall and then we learned about the Berlin Wall coming down. Believe it or not, as a child I wanted to become a mathematician, but then I decided to study medicine. And now I'm doing basically both. The wall we want to bring down with our research is the wall around our data. If we have data locally, we store them and process them locally, and we keep them safe by putting firewalls around them. And this is not only us, everybody in the world is doing this. So we have all these isolated data, which does not allow us really to apply things like artificial intelligence and machine learning, where we need a lot of data. Yeah, so this situation with many walls, we have to overcome. Over the last 20 years, people have thought about to bring all data to a central place, and we call that now the cloud. So now the data is in the cloud, also locally for backup. So we duplicate the data, and now we can calculate them all here. But particularly for medicine, this is not the best solution because of data protection laws and other regulations in the world. It's not so easy to bring them all to one place, and it's also not our medical tradition. So to overcome the problem of local walls and regulatory walls that do not allow us to put it into the cloud, our innovation will overcome this hurdle. So what is the new finding, the new innovation? Our innovation is swarm learning to bring down these firewalls, these walls around data. Here we show in this picture, different sites, could be hospitals, could be research institutions where data are produced, where data are processed, and now we bring them together in a way that the data are staying at these places. We bring the models and the algorithms to these institutions, and we agree on a contract which is built into a privacy-preserving blockchain. How are we dealing with each other concerning the data, the algorithms, and what rights and responsibilities we have? And this allows us to share the knowledge. We do not share the data, but rather the knowledge. And now we can apply artificial intelligence and machine learning applications at the edges, and in iterative processes learn together without sharing data, but only sharing knowledge. By this, we democratize the data application, and we do not need a central player anymore. Does this work? Yes, it does. We demonstrated that by using blood transcriptomics from patients, and could identify or predict patients that either had a leukemia or a tuberculosis, or even patients with COVID-19. So what are the benefits for medicine and for society, of course? Well, for medicine, swarm learning is basically building on medical traditions. In medicine, we're not very good in sharing data, but we're very good in learning together. And that's exactly what swarm learning provides us. We learn together, but we do not share the data. The knowledge is the important thing that we have to share. And by this, we can now apply AI and machine learning because we have access to more data without sharing it. And I think this will be the enabling technology for precision medicine. So swarm learning, AI, and sharing knowledge within a swarm of institutions, hospitals, even across the world. So by this together, we create much more value and knowledge in a much faster time. But this is not only for medicine, which of course has an impact on society itself, but it will be in other areas as well. So it's beyond medicine. We could imagine autonomous driving. Each of these dots would be a car, smart cities, energy grids, and so on and so on. Wherever you need data from many people, many institutions, many regions, where you cannot share the data, but you could share the learning and the knowledge in the end. So what are the unanswered questions? The principle of swarm learning is crystal clear. The next steps we have to do and show is that we can translate that to clinical practice. And this is exactly what we are doing now. We want to bring it to the patients so that patients can benefit from that.